a look at your warm-up. So I wanted to give you some answers. See how that looks. So your answer to your first one, the slope is 1/2. For B, your slope is -1/2. For C, your slope is undefined. For D, you get that 0 out of -9. Talk about weird, -9 pieces of cake. What? Yeah, you get 0 out of -9, and that's 0. Chickadee check yourself, kids. Did anybody get any of those wrong? No? Okay. Example 1. Maybe that's it, yeah. My students will get 2 things mixed up with regard to their warm-up answers, like every year. And I don't know if I've done this already, but this comes at you courtesy of Pinterest. Yes, so many math teaching boards on my Pinterest account. It's amazing. Okay, so what I'm talking about right now is, you know, you might have a number like 0. Oh, well, helps if I have a pen, right? So, like, if you have 0 out of 2. Or you might have 2 out of 0 as maybe one of your answers, something like that, right? I teach this in 2 ways. One, I like to talk about food because, well, I haven't had my breakfast yet and I'm starving. But do you see how we have 0 out of 2? Let's say we're talking about cake. Yummy, delicious cake. You show up at a party and you're all excited because there's cake. But unfortunately, the host is like, you get no cake. You get 0 out of the 2 pieces of cake. How much cake did you get? You get 0 cake and you're sad. Because life without cake is miserable. Okay, now this guy over here. 2 out of 0. Okay, so you show up at the same party. And you're like, hey, I need 2 pieces of cake. But they're like, hey, there's no party. There's no cake. What are you talking about? You can't take 2 and divide it no ways, right? The division never happened. There was no cake to begin with. So people look at you like you're crazy, right? And in that case, we can say that that value is actually undefined. And undefined in math class is just 0 with a slash through it. Okay, wait, it gets better. This is the Pinterest part. You ready? So, the moral of the story, if you have 0 over a number, n is any number you want. If you have 0 over a number, it spells the word. It's on. It is on, game on, you get an answer, your answer is 0. However, if you have a number over 0, that spells no. Ah. And that is not possible. That is undefined. Did I give you that speech before?
Oh.
Yeah. So if you have 0 over a number,
You got it.
You get an answer. Draw the line. It's going to pass the vertical line test. It's amazing. So game on if you have 0 over a number. But if you have a number over 0, no! It is not possible for that particular set of ordered pairs to pass the vertical line test. Your slope is going to be undefined. It's going to make a vertical line. And that is what we are talking about today. So just categorize, could I say that word? Categorizing a line based on its slope. Where we're heading to next. And the idea, again, behind today's lesson is to sort of categorize our lines based on the slope. So let's do that. All right, so all I did, if you take a look at example 1 here, it says take another look at our warm-up problems. For each problem, you're asked to determine if the corresponding line would be increasing, decreasing, vertical, or horizontal. So what did I do? You know what I do. I draw a picture. So I drew myself an X and a Y axis, and I gave myself a couple of tick marks, and then I plotted those points. I plotted the point 0, 0 and the point 2, 1. And then I connected the dots. What I noticed is that that line went up. In other words, as X was increasing, Y was also increasing. So whenever our slope is positive, or as the big kids are going to say, whenever your slope is greater than 0, you're going to get that increasing line. Now for the next part, remember, don't write it down if you don't understand it. Again, I drew a picture to start with because I'm a visual person and I know some of you are too. So I drew my XY axis. I added on a couple of tick marks. I then plotted the point 2, 1, and then negative 2, 3. And I connected those dots. What I noticed was like a line that didn't go up this time, it goes down. And you don't have to actually draw the picture. If you notice the slope is negative, we are allowed to assume that that's going to be a decreasing line. So the idea is that hopefully after today's lesson, you don't actually have to draw a picture. You just begin to understand that if we have a positive slope, the line increases. If we have a negative slope, aka a slope that's less than 0, we get a line that decreases. There's that guy right there. Oh, wait, but there's more. Right? You saw 4 different slopes in your warm-up. So let's talk about what happens if you get a undefined slope, or an undefined slope. Ugh. If you were going to go ahead and go back and plot those points from the warm-up, so I could draw a picture, add one in for fun. I'll steal the points off of Kelly's paper here. What do we got? We got 2, 0, and 2, 2. Over 2, up 0. And then over 2, up 2. Check it out. Look at that. That's a vertical line. And that is what we call, that is how we get an undefined slope there. So when your slope is undefined, you're going to end up with something that's straight up and down. And then the last one, oops, that's not what I wanted to do, is that. If your slope is 0, there's no rate of change between your points. There's no up or down movement there. And again, you could draw a picture if you had to. Ideally, if you start to notice that your slope is 0, you just know that that's going to be a horizontal line. But they did give you a couple points. They gave you, what, 4, 2, 1, 2, 3, 4, up 1, 2. And they gave you negative 5, 2. 1, 2, 3, 4, 5. On the negative end, 2. So that right there is your horizontal line. So the idea is that you can use these describing words to tell me about the line just by looking at the slope. So we have increasing, decreasing, vertical, and horizontal. All right, so now we get to use this information to help us graph lines a little bit. Slope-intercept form of a line is that y equals mx plus b right there. All right, for just about, I'm going to give you exactly 1 minute. Okay, I'm going to say go here in a minute. What are you going to do? You're going to fill in that rectangle with as many possible things you know about y equals mx plus b. So what do you know about y? What do you know about m? What do you know about x? And what do you know about b? I'm going to give you exactly 1 minute. Ready, set, go. Okay, I won't call on you. I walked around a little bit while you guys were working. I'm just going to tell you what I saw, okay? The first thing on almost everybody's paper that I just walked up this middle here. First thing I saw, a little bit of information about that m right there, which probably comes from the warm-up. Yeah, m is our slope. Some of you even had the formula y2 minus y1 over x2 minus x1. Remember, it is a rate of change. So not only is it equal to our slope, but it's equal to a rate of change in a word problem. Or, some of you might remember I said, say everything. This could also be our rise over run. Because it is a change in our y values, our up-down motion, over our change in our x values. That's a little delta right there. That little triangle, delta, means change in. So we say that delta y up top there is change in y, delta x is change in x. The next thing I saw, this b value, that is your y-intercept. In other words, the place where the graph grabs on to the y-axis. It's usually a point 0, comma b. Now there are some things that you could add on with regard to x and y. Like x is your control variable, y is your dependent. But more commonly than not, when we put this x and this y together, we just get ordered pairs that sit on that line. So the x and y, when we plug them into our equation, just give us points on the line. Which I think, that's probably the obvious thing that you're like, oh yeah, but you didn't think to write it, because it's super obvious. In order to graph a function, and again, you're going to want to grab some graph paper for tonight. Let me give you a couple steps here. First thing I always do is make sure it's in that y equals mx plus b form, so that I can clearly identify my slope, clearly identify my y-intercept. Then I start graphing by looking at the y-intercept in the problem. So in this problem, my starting point is that b value of 1 right there. So I'm going to graph the point to start. I'm going to start at 0, comma b, which in this case is 0, comma 1. So I go over 0, up 1, and I put it up. Then they give me a little bit of information about my slope. So my slope in this problem is 2, which is like 2 over 1. So if I'm thinking about this as a rise to run, see how the rise is positive 2? That means I'm going up 2 units. And my run is also positive, so this means I'm going to the right 1 unit to get to all of the other points on the line. So from my red dot right there, I'm going to go up 2 and swoop to the right 1. Up 2 and swoop to the right 1. Up 2, swoop to the right 1. We can also repeat this pattern in reverse, because you're also supposed to have some negative x values there. So in this case, I would go down 1, 2, swoop to the left 1. If you went the wrong way, you wouldn't have a line anymore. So, okay. But again, you want some negative x values, some positive x values, and 0 anytime you go to graph. So you get a whole graph. All right. Part B. Same thing. So we have a starting point at 2. So that's always where I start. So I'm going to start at 0, comma 2. So I go over 0, up 2. And then I get a little bit of thought to my slope. This time around, my slope is negative. So my slope in this problem is now negative 3, which is like negative 3 over 1. Any integer you can just put over 1 to turn it into a fraction. And then I'm like, okay, well this time around, my y values, my change in my y's is negative 3. So change in y is negative 3. That means I'm swooping down 3 units. And then that's still a positive 1 on the bottom, so I'm going to go to the right 1. So from my red dot, I'm going to go down 1, 2, 3 to the right 1. And do you see how you get that decreasing line because the slope was negative? So from our first example today, when our slope was less than 0, our line is trending downward. So this one's even steeper, but it goes down. And you don't have to draw those swoopy things in there. I just wanted you to kind of see what's going on in my head a little bit. Okay, questions about that? Next up here, a little bit about graphing horizontal lines. You see how there's no x's there? You get 0x, the slope of 0. Y equals a number is just a horizontal line. I'll give you a cool way to remember that tomorrow. But basically, I let the equation be the boss, always. So it's telling me, hey, Lucas, go to where y is 2. So that's what I'm going to do. I'm going to go on the y-axis where it's 2. I'm going to draw a horizontal line. And then I'm going to go to where y is negative 3. I'm going to draw a horizontal line. And our last little bit of the day. This one isn't in y equals mx plus b form. Hey! So annoying. But we could write it in y equals mx plus b form using our mad skills from the beginning of the chapter. So here I would subtract x from both sides. And we get y equals negative 1x plus 2. So I would graph it just like I did before. Or here, in this last one, I would get this y by itself just by subtracting 4x from both sides. And then I would do what I did before, which is probably where we're stopping for today. So I will go over number 44 tomorrow and then check those word problems. And then you have a little bit of bookwork tonight. Don't forget to grab some graph paper on your way out. As you can tell, you will be graphing a little bit. And this is where we'll pick up tomorrow.